In this video, we're going to continue to develop our techniques that we have for counting different number of objects in different situations. In particular, in this video, we'll talk about something called arrangements and also a math notation called factorials that is really convenient for arrangements. So first, let's look at a situation. So let's say you have 4 friends and you want to rank your 4 friends from your favorite to your least favorite. So the question is how many ways can you do this? When I'm working these problems, I always like to think of it as if I'm putting things, or in this case people, into slots. So here we have 4 friends and we're putting them into 4 slots. One is like first place, our favorite friend, and on down. Now I do want to say that I am in no way condoning ranking your friends. I'm just using it as a math example. That's all. So then if we're choosing our friends, when we choose who is going to go into the first place slot, we have 4 choices, all 4 of our friends. But once we choose who is first, that means we only have 3 choices for who we might put in the second slot. And then continuing on, this leaves us with only 2 choices for the third slot. And finally, once we have all those friends chosen, we only have 1 choice for who gets to go last. Now, that may not be the order that you would actually choose them in, but it makes no difference. So, for example, let's say it's easier for you to decide who your least favorite friend is first. Well, then you would have 4 choices of who your least favorite friend is. And you're debating between first and second, but you can then move on to your second to the least favorite. And then you decide that Bob's your favorite, so you go ahead and choose that one next, leaving you with only 1 choice for second place. It doesn't matter what order you choose them in that sense, but the idea is that you're using up the choices as you go through them. So I went ahead and switched it back to 4, 3, 2, 1 because that's the more normal way of looking at it. So we made a choice for the first, then second, then third, then fourth. Now, the question is then how many different ways are there to do this? Well, what we saw with the fundamental counting property is that we can multiply up how many options we have at each layer of a decision to give us the total number of options. So we're just going to multiply 4 times 3 times 2 times 1. And that's going to give us 24. So there's 24 different ways we could arrange our friends from first to last. Now, in all reality, there's only 1 choice, right? There's only one that's first place. But this isn't saying in actuality. This is saying what's the potential different ways that it could land. So that's the idea. This is basically the fundamental counting principle, which we've already worked with, except now as we go through the layers of options, we're using up our options, our choices for each layer, and so we end up counting downwards like this. Let's do one more that's a slightly different scenario and see how else it could work. Alright, you have 10 cars and you have a 10-car garage. The question is how many different ways can you park your 10 cars in your 10-car garage? Again, I like to think of this as slots, and garages are kind of literally slots, so this helps solidify that way of thinking. Alright, so there are 10 garage slots, and then we're going to place cars in them. Well, before we place any cars, we have 10 cars to choose from, so we have 10 choices for which car I park in the first garage. And then once I park that one, I have 9 choices for which car goes in the next garage, and then on down. Hopefully the logic of this makes sense to you and you're not just kind of saying, oh, so we just count down. Because as we develop more counting techniques, you'll need to understand the logic of it to know when to choose which technique. So here the idea is as I park cars, I have fewer cars to choose from to park my next car. And so the number of options on each slot is going down by 1 as I park the cars. And then my fundamental counting principle tells me that the way that I get my answer for this is to multiply up all the options. That's a really big number. So this takes us to the next idea that we're talking about in this video, and it's called factorials. This idea of arrangements that use up the options as we go down through is common, and in math, if we have something that's going to happen a lot like this, we end up developing a notation for it. And factorials is the notation that we use for this. So basically, instead of writing 10 times 9 times 8 and so on, we just write a 10 with an exclamation mark after it. And that's not the same as the grammatical exclamation mark. It's not excited. You don't have to scream it. That just means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we don't say 10 exclamation mark. We say 10 factorial, because it is a factorial, that exclamation mark symbol is. So as you can see, it actually saves a lot of writing. And we use this for any number, so like if you have 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1, and so on. Factorials are only used for your whole numbers, so 0, 1, 2, 3, 4, and on. To have a factorial of a decimal place doesn't make sense. To have a factorial of a negative number doesn't make sense. One thing that's important to note is that 0 factorial equals 1 by definition. It doesn't really follow the pattern of the other factorials, but we do need a 0 factorial, and so by definition we just say it's going to be 1. So if that ever comes up, it just equals 1. Okay, so when you're doing your 10 cars in your 10 car garage, it is acceptable instead of writing the 10 times 9 times 8, unless if you need to write this out to help you think through it, by all means do it, but it is sufficient to just write 10 factorial. And then as far as what that equals, if you have a scientific calculator, it's going to have a factorial button on it somewhere. And the different calculators have it in different places, but if you look around for an exclamation mark, that wherever that is, that means factorial, because it's the only way we use it in math. So if you're having trouble finding that, feel free to ask me, and I can try to point you in the right direction. But you don't need to put 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 in your calculator. You can just put 10 factorial, and your calculator will calculate it for you. So I did just that, and I got 3,628,800. Nice fancy number. So that's the idea of factorials. Arrangements are taking a certain number of items and arranging them where you're using up each of the options as you go. And so you're counting down, and then you multiply them up according to the fundamental counting principle. This results in this descending counting, and so we're going to use factorials to denote that. Go ahead and give some of these a try and see how you fare.